Welcome back. In this video, we will talk about factorial and fundamental principles of counting. Say there is a pack of tokens, and from there we have selected 3 tokens. One is red, labeled A, one green, labeled B, and one blue, labeled C. Now there is a table, and we have to put these 3 tokens on this table in a line. Now in what ways we can do this? First, we may select this red token and put it on the table. This A is over here. And then we have B and C. Now out of these 2, we may select B so that B comes over here and then C is there. So C will come over here. Now it may happen that after selecting A, we may select C first so that this B becomes C and this C becomes B. Now if we select B, then after selecting this B, we may select A or C. Now if we select A, then C will be here, and if we select C, then A will be here. The same way goes when we select C first, then A and B will be there, or B and A will be there, right? Now initially we had 3 ways or 3 options to select those coins, and after selecting a single coin for the first time, we had 2 ways each for the rest of the 2 coins, isn't it? And after selecting the second coin, we had only 1 option left for us, that is 1 way, right? So for selecting 1 way, you had 2 cases, right? Or 2 options. So you can write here 2 times 1 way. Here also 2 times 1 way. Right? Now think of this 2 times 1 way as a whole unit. So this is another unit and this is another unit. Now you see that for having one of these units, you have 3 ways. 3 times 2 times 1 way. That is, mathematically you have 3 times 2 times 1. So these are the different ways you can arrange those 3 coins on this table in a linear fashion. This kind of notation of numbers, that is starting from any natural number n and gradually multiplied by the consecutive numbers up to 1, gives birth to the concept of factorial. So we have factorial of n as n times, n minus 1 times, n minus 2 times, gradually it will go up to 1. Of course, you may have the sequence in the reverse order also. You may start from 1, then 2, then 3, and then n minus 1 and up to n. Now clearly from here you can write the formation in this way also, that n factorial equal to n times n minus 1 factorial. Because you can see that the factorial of n minus 1 also goes up to 1. So this whole sequence can be written in this form also. Clear? Now we will do 2 exercises for converting a given sequence in terms of factorial. Now to convert this form to a factorial form, you need to have those terms up to 1. So what you can do like this, that by forcefully you can do like this, that 1.2.3.4.5, 6, 7, 8, 9, and then you provide the penalty as 1.2.3.5. So on the upper side, you have got factorial of 9, and on the lower side, you have got factorial of 5. So this is the factorial form of the given expression, right? We can do another one. Say they have given you 8.12.16.20. What you can do, you follow the pattern here, okay? You just follow the pattern. Now what you see here is that 8, 12, 16, 20, that means it is a multiple of 4. So what you can do is that 4.2, 8 has been replaced with, right? Dot 4.3 for this 12. Dot 4.4 for the 16.4.5 and you got 20 here. Now you do one thing, you just rearrange these numbers, okay? So 4.4.4.4, these 4s, and the rest of the thing on the other side, like this. So you see that 4 raised to 4 dot 2, 3, 4 and 5. You have got it like that, right? Now you can see that the formation is very simple. 1.2.3.4.5, because this 1 was missing, but we can push it inside because it does not change anything inside. So ultimately we have got 4 raised to 4 dot factorial of 5. Clear? Now we will talk about two fundamental principles of counting, right? The first one is principle of multiplication and the second one is principle of addition. First we talk about principle of multiplication. You follow this principle when you have this situation that you want 2 or more jobs to be done sequentially. That means if you have been given 2 jobs, then 2 jobs must be done. Of course, sequentially, one after another. Whenever you have this kind of job, then you follow the principle of multiplication. So the notation goes like this, that when your first job can be done in m distinct ways, follow the word distinct. That means the ways are unique. And there is a second job that can be done in n distinct ways, then both jobs can take place, of course one by another, in m times n distinct ways. For example, if first job can be done in 3 ways and the second job can be done in 2 ways, then 3 times 2, that means 6 ways will be there to perform both the jobs, right? We go for an example. Suppose there are 5 boys and 3 girls and we need 1 boy and 1 girl, okay? So follow this word and. That means we need 2 children from this group and this group, okay? 1 from each of these groups, right? Now we will go for finding out in how many ways that pair can be created, okay? Suppose we go for boy 1. If we select boy 1, with the boy 1, we can have a pair with G1, right? So this is one way. We can also have boy 1 with G2, or we can also have a boy 1 with G3. So we have got 3 ways from this figure, isn't it? Now if we go for boy 2, suppose we have selected boy 2, then with boy 2, you can have the pair with G1, you can have a pair with G2, and you can have a pair of G3, any one of them, right? Next we can have this figure, and this figure. So each time a boy is selected, we can have one of the girls from this group with that boy, isn't it? So start from the downward, we have 3 ways to select the girls. So here also 3 ways, right? 3 ways. And here also 3 ways. And we can have 5 ways to select the boys. So you can see that from each way of the boys, we can have 3 ways for the girls. So one way produces 3 ways for the girls. So if there are 5 ways for the boys, you have 5 times 3 ways for selecting 1 boy and 1 girl from each group, isn't it? So this is the principle of multiplication, that when you have and between 2 groups, then you apply the principle of multiplication. Now we go for principle of addition. The scenario goes like this, that if you have 2 or more jobs, only one of them is to be done. That means you have to select any one of them. The point is, in how many ways you can select one job from 2 or more jobs. We go by the statement. If you have a first job that can be done in m distinct ways, and you have a second job that can be done in n distinct ways, then one of the two jobs that can be done in m plus n distinct ways. Now we see through an example, the same example we use now, that there are 5 boys and there are 3 girls, and we have to select one child from these two groups. That means either one boy or one girl. So here is the thing you have to notice. Previously here it was and, now it is or. So you see that out of these 5 boys, how many ways you can select one boy from this group? Of course, 5 ways, right? And out of these girls, in how many ways you can select one girl? That is 3 ways, right? Now think it in this way, that there are no boys and girls groups. There are total 8 children and you need one child from these 8 children. Because our question says that you may have one boy or one girl. That means the gender doesn't matter. You need one child from these 8 children. So if I say that in how many ways you can have one child from these 8 children, of course it will be 8 ways, right? It's total 8 ways. Now when you see in the form of groups that there's a group of 5 children who are boys and 3 children who are girls, then you can have group wise. That means 5 ways for the boys and 3 ways for the girls. Now if you add these two, because the groups will be added to form the total 8 children, definitely the ways will also be added, right? So you have in total 8 ways here. That is why m plus n distinct ways has been mentioned here. Clear? The first practice will be like this, that we need number plates of vehicles, and those number plates will carry first 2 different letters from English alphabet, followed by 4 different digits from 0 to 9. So the scenario goes like this, that we have the alphabet and we have 10 digits from 0 to 9. From this data source, we have to create the number plate like this. These are the 2 cells for English letters, and these are the 4 cells for digits. Right? Now you start from the left, start from this cell. In how many ways you can fill this box? There are 26 letters. So we have 26 ways for filling up this box. So it may be A, it may be B, it may be C, it may be D, any one of these 26 letters, right? So we have 26 ways to fill this first box. Now we go to the second box. See the question here, different letters. That means whenever one of the letter has been placed here in this first box, you have 25 letters left over here in your data source. Okay, so we have 25 ways to fill the next box. So this part is over. Now you see here, the first box of the digit. First time you will get 10 ways because all the digits are available to you. Now whenever one of the digit has taken place over here, you have 9 digits left, because here also the same thing given, that different digits, right? So you have 9 options. So when 2 of them have been placed here in these 2 boxes, you have 8 options left, and here you have 7 options left, right? Now you start from the right. You have 7 options, but there are 8 ways you can have 7 options, right? So you have got 8 times 7. Now when you got this 8 times 7, this figure, in how many ways you can have 8 times 7? It is 9 times 8 times 7, right? Now when you have this 9 times 8 times 7, the whole thing, in how many ways you can have this whole unit? You can have 10 ways to have this whole unit. Now when you have the whole unit like this, in how many ways you can have it? You can have 25 ways, right? And for this whole unit, now you go like this, you can have 26 ways. So you have 26 times, 25 times, 10 times, 9 times, 8 times, 7. And you find the number, and those are the different ways you can have the number plates. Clear? Okay. We go for the same type of problem, but this time we will have 2 different letters and any 4 digits from 0 to 9. The meaning is that you may have repetition of digits. So you have this data source, and here are the boxes for your number plate. Now the first two boxes will have two letters from this alphabet. Okay. Now here two different letters has been mentioned. So we have 26 options for this box and 25 options for this box, because one of the letter will be going inside and that is not allowed to repeat. Then you have 25 letters left, right? And for this box, we have 10 digits. So 10 options are there. Any one of them you can place inside here. And since it is telling any 4 digits, that means it is allowing you for repetition, then you can have 10 options for this box also, and 10 options for this box as well as for this box. So apparently it seemed to be correct that 26 times, 25 times, 10 times, 10 times, 10 times, 10. So you multiply this thing and get that number, and that will be the number for having different ways to have number plate. Now here in the bracket you see that a number plate cannot have all zeros. But here in your calculation, there may be 4 zeros like this, right? Because each time you have taken all the 10 ways for these boxes. Now you can avoid this situation. If any one of these boxes can be made non-zero, then it conforms to the question. So what you have to do, you go like this, that you change this 10 to 9. So when you go for 9 like this, then this will be 9 times, right? So, or 9 ways. Of course, you can keep this 10 over here and make this as 9. Or you can make this 9, or you can make this 9. So any one box, you give options 9 times or 9 ways. Then that calculation will be according to this given question. Okay? In the next video, we will go for permutation and combination. Now before that, if you have any kind of question, you may write in the comment section and I will definitely respond to you.